In chapter 19, we were talking last night about impedance matching, and there was a question in regards to we needed to make sure that the power in the primary and the power in the secondary are equal, because if we look at this circuit, we know that if we use a transformer, and we use transformers to do impedance matching, so if we say there is a transformer here, and we have a ratio of NP to NS, that's primary to secondary. So the power over here should equal to the power here. That is the goal of this this project here. So if we say VG is 10 volts, and then we have RI. RI is your generator. So this is your generator, internal resistance of your generator. And this ZP is your impedance of your primary, which was going to be equal to your RI of your generator. So these two are going to be equal. So in our circuit, we have RL, which is equal to ZS. Now this ZS right here is your impedance of the secondary. So we have impedance of the primary, impedance of the secondary. This secondary impedance will change if you have capacitors and other inductors and resistors in here too. So just keep that in mind. For now, we don't have any other active or passive components. We just have one resistor RL, which is called a load, which is equal to ZS. So that's the reason why ZS is equal to RL. So if we want to know what the power in the primary, and that's the load, the primary load power is equal to VG, that's your voltage in the generator, over RI plus RL, and we square it times RL. So if we do it this way, we have 10 volts over 208 times 8. So again, 10 divided to 200 plus 8, square it, times 8 gives us 18.49 milliwatts of power. So the next part we want to do is actually look at the turns ratio of this circuit. So we could say that NP is equal to NS is equal to the radical of the square root radical of ZP over ZS. In this case, NP over NS is going to be equal to the radical of 200 over 8. Since this is a square root, we're going to get 25 over 1, which gives us a 5 to 1. So this is going to be equal to NP over NS. Keep that in mind. Next part we want to do is take a look at the power in the primary, and that's over here. And that's just VG squared over RI plus ZP. And we're going to square it. I made a mistake. It's actually VG over RI plus ZP, and we squared this whole thing, not square VG. So this is squared. So this whole equation is squared, times it by ZP. And that gives us 10 over 200 plus 200, which is 400, and we square that. Times 200 gives 125 milliwatts. So that's our power in the primary. So we want to know what our power in the load is, and we want to see if it's going to match up at this point. So if we actually look at the equation, the final part of this is we have to find the voltage in the secondary. The voltage in the secondary is the number in the secondary over the primary, times it by the voltage in the primary. Since RI and ZP are equal to 200 ohms each, VP is equal to 1/2 of VG. So that means that this 10 volts is going to drop 5 volts here, and it's going to drop 5 volts there. So if we actually take this 5 volts right here, and we plug it into the turns ratio 1 over 5, we get 5 divided into 5 gives us 1 volt on the secondary. This is a step-down transformer because we have, in this case, this is a 5 to 1. Since the 5 is on the left side, this is a good way of looking at it. Since 5 is on the left side and 1 is on the right, since it's this way, we know this is going to be a step-down transformer. If it was reversed, it would be a step-up transformer. So the final part of this is actually look at to see if we do have impedance matching. So what we're trying to do is match the power in the primary, which is right here, and we should get the same power in the load or power in the secondary. So we take VS squared over RL, and we take 1 squared over 8, gives us 125 milliwatts. So we can say this is matched. So the problem we had last night was I did not take half of the voltage of the generator because I did not take into account the fact that Ri and Zp are the same. Now Ri is your generator impedance, and this is going to be something that's going to be manufactured by the person who designs it. This is Zp right here is your impedance of your generator. So these two will be the same again. If you have any questions with this, please feel free to reach out to me.